All right, so we are starting to talk about Newton's laws of motion. This first little piece that we're going to do is his first law, and essentially it's about inertia, okay? So I want you to fill in the blanks on your note page as we go along. What is inertia? This is a definition for us. The property of matter that resists change in motion or direction unless acted upon by an unbalanced force. So that is our definition for inertia. So this is that, I guess, famous law of motion that says an object in motion will continue to stay in motion unless acted on by an unbalanced force. Or it goes, an object at rest will stay at rest unless acted upon by an outside force. All right? That's the actual law itself, and that's another way of describing inertia. Some key bullet points for inertia. An object will keep moving at the same rate, or an object will stay at rest. An object will continue in the same direction. Okay? And then the last two, the more mass something has, the more inertia it will have. Okay? The less mass is less inertia. Once you finish writing, I will kind of explain that and help you picture it a little bit better. Okay, so in terms of inertia, say that I am going up against the Hulk. Okay? I don't know if you know who the Hulk is, but he's like a giant green dude, and he's really, really strong, right? So if me and the Hulk are facing each other, and we both start pushing, which one of us is going to move?
You.
I am, right? That's because I have less mass, I have less inertia. So what inertia means is that it's hard, so if the Hulk is standing still, it's going to be hard for me to get him to start moving because he's so big, he has a lot of mass, right? If the Hulk is running, okay, the Hulk is running at me, it's going to be hard for me to sit here and stop him completely, right? He's probably just going to plow me over because he has a lot of mass. That's what inertia is, okay? The heavier something is, the harder it is to get it to start moving, the harder it is to get it to stop moving. Okay, if you think about a bowling ball and it's just sitting there, it's harder to get that to move than it is a marble because bowling balls have more mass. Okay, also if somebody like yeets a bowling ball at you, it's going to be hard to stop it because it has a bunch of weight to it, it has a bunch of mass. If somebody throws a marble at you, you can just catch it. Does that make sense? Okay, so inertia is just basically how hard is it to stop that thing that's coming at you really fast. Okay? Let's keep going. Some examples of inertia. I don't think I'll have to write anything here. Your body flies forward when you slam on the brakes of your car. Okay? So you're like cruising down the highway, you're going 70 miles an hour. You slam on the brakes because of the deer. Your body wants to continue going forward because of inertia. And that's why you sometimes get whiplash. It's a lot of fun. A book in the back seat of your car will continue forward at the same speed of the car. Okay? If you're slamming your brakes and you have something like sitting on the console of your car, it's going to go flying through the dashboard, right? And that's because of inertia. Roller coaster suddenly turns and your body feels like it's thrown to the outside of the circle. Things like that. Okay? Can y'all picture inertia? Does it make sense? All right. Now, let's talk about it in terms of Newton's first law of motion. Okay? Most of matter is in space, so constant motion without an outside force is considered the normal event. Earth is considered to be a special case given that we have friction. right, and then we have the meat of our notes right here, Newton's first law of motion. Okay, this is Sir Isaac Newton. An object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an outside unbalanced force. He published his first law in 1687. It is true in outer space, on Earth, underwater. It's true everywhere. It's also referred to as the law of inertia. Okay, so let's talk about this. It's easier to talk about this as if we were in outer space because we know outer space doesn't have gravity. It doesn't have any other forces. It doesn't have air resistance or anything like that. Okay? So if you're in outer space and you throw a baseball, what's that baseball going to do after you throw it? It's going to, so if I throw it at 65 miles per hour.
It's going to continue to go 65 miles an hour forever.
Yes, it's going to continue that forever. Until, one, it runs into something, or two, if it gets into like Earth's orbit and then gravity affects it. Okay, but gravity is one of those forces that this is talking about, unless acted upon by an outside unbalanced force. Okay? The reason why on Earth, if we throw a baseball at 65, it's eventually going to stop, is because Earth has gravity, and then whenever it hits the ground, it causes friction as well. Okay? Those are two forces that stop the motion of that baseball. Okay? If we're in outer space, it's a different story. We don't have friction, we don't have gravity, so it'll just keep going. That's basically what Newton's first law is trying to say. Okay? That's it on that. Now, we are going to write down some vocabulary. So, this unit's vocabulary is green paper.